Hello everyone. This video will give you an introduction to complex numbers. Okay, now the main part of a complex number is the number I. Yes, for complex numbers, I is not a variable but an actual number because I is equal to the square root of -1. Okay, so the what you call imaginary number I, we know that I is equal to the square root of -1. Okay, so if we square both sides, we see that I squared is equal to the square root of -1 squared. Now, if you remember, square root of -1, you can write that as -1 to the 1/2 power. -1 to the 1/2 power, and that's still squared. Okay, so we get the power rule, or the power rule for exponents. Those two multiply and cancel out. So we're left with I squared equals -1. Okay, so we know that I is equal to the square root of -1, and I squared is actually equal to -1. Okay, so before we get into our first example, I want you to remember that the nth root of a times b is equal to the nth root of a times the nth root of b. You can separate them. Okay, now with that in mind, we're going to go ahead to our first example. So if you're still writing, feel free to press pause. All right, so let's say, for example, we want to write each expression in terms of I. Okay, so let's say for problem A, we have the square root of -9. Okay, let's say for problem B, we have the square root of -7. Okay, so let's say for problem C, we have negative square root of -18. And let's say for problem D, we have the square root of -24 over 49. Okay. Now, normally, if you remember, if you have the square root of a negative number, you'd have to find the value that multiplied to itself to give you -9. But since you can't use +3, because +3 times +3 is +9, and you can't use -3, -3 times -3 is also +9, we're going to have to kind of separate it. So for problem A, you have the square root of -9. Okay, since you have -9, that's actually equal to the square root of 9 times -1. Kind of separate those with parentheses. Now remember, when you're multiplying, remember the rule we had before, you can separate them when you multiply the two factors under the root symbol. So that gives you the square root of 9 times the square root of -1. Okay, now remember, square root of -1 is equal to I. So square root of 9, it's positive or -3, but we're just going to use the positive. So square root of 9 is equal to 3, and square root of -1 is equal to I. Okay, so square root of -9 is equal to 3I. Okay, so if we go to problem B, we have square root of -7. Okay, we know that's equal to square root of 7 times -1. Once again, if we separate those two, we have square root of 7 times square root of -1. Square root of -1 is equal to I, so this is just square root of 7. And the I, remember that's on the outside, so you can put the I either on the right or the left, doesn't matter. Okay, so your answer is square root of 7 times I. Okay, be really careful not to put the I underneath the square root symbol. It's not supposed to go there, but it's a really easy error to make. So you want to make sure your I is on the outside of the square root symbol. Okay, so for problem C, we have negative square root of -18. Okay, that negative on the outside, it just travels right along with it. So you have the negative on the outside and the negative up underneath. We're just going to make that 18 times -1. Okay, and just like before, we're going to go ahead and separate it. So that's equal to negative square root of 18 times square root of -1. Okay, so remember that negative in front is just like multiplying it times -1. Okay, it's just -1 times that. So if you separate, it's still that -1 up in front. Okay, so if you look carefully, that square root of 18 is not a perfect square, but it has a perfect square as a factor. Okay, so square root of 18, put that on the side. Remember, that's equal to square root of 9 times 2, which is equal to square root of 9 times square root of 2. Square root of 9 is positive or -3, but we're just going to use the positive. So you have 3 times square root of 2. Okay, so you have that negative. And square root of 18 is 3 square root of 2. And that square root of -1 is I. Or, in some cases, what they would do is write it as -3i square root of 2. Either one of these would be correct. Because remember, that I, you're just multiplying it. Just like 2 times 3 and 3 times 2 can be the same thing. 3 times I and I times 3, same thing. It doesn't matter when you're multiplying, you can switch them right on up. Okay, and for problem D, if you have the square root of -24 over 49, remember that's the same as saying the square root of 24 over 49 times -1. Which means you can go ahead and just separate those two. And you will get the square root of 24 over 49 times the square root of -1. Okay. And also, if you remember your rules for separating separating fractions, you can separate that into two separate root functions. So you have square root of 24 over square root of 49, and square root of -1 is I, so you have that times I there. Oh, move that up a little bit. Okay, now the square root of 49 is a perfect square. The square root of 24 is not, but it has a perfect square as a factor. Okay, so square root of 24, we can make that square root of 4 times 6, which equals square root of 4 times square root of 6. Square root of 4 is positive or negative 2, but we're just going to use the positive. Square root of 4 is 2 times square root of 6. Okay, so square root of 24 is 2 square root of 6. Move that up a little bit more. So 2 square root of 6 over square root of 49, which is 7i. Okay, so you can put it like that, or you can put that I right up there and make it 2i square root of 6 over 7. Either one of those would be correct. All right. Going to go ahead to our next page. Good. There we go. All right. So those examples in general you can have for a positive real number b, square root of negative b is equal to I times square root of b. So really all you have to do is get that negative b and make that negative into an I and have that b as positive. And the reason they say that for positive real number b, because if b is negative, you have the negative of a negative number, it will come out positive. So if b is positive, you have the negative of a positive number. Okay. Now we're going to look at what they call the general form of a complex number. Okay, so a complex number is any number that can be written in the form a plus bi, where a and b are real numbers. And I equals the square root of -1. Okay, now to kind of break that down a little bit more, for a plus bi, they say the number a equals the real part, and they say the number b represents the imaginary part. Alright, so let's go to a couple of examples. Okay. Let's say, for example, if you have 2 plus 11i. Okay, so the 2 would be your real part. So in this case, a would equal 2. And the 11 would be your imaginary part. Or in this case, b is equal to 11. Alright, what if we have, let me kind of separate that a little bit. What if we have the example 6 minus 9i? Okay, so in this case, the 6 will be your real part, so a would equal 6. And this would be your imaginary part. But in this case, b would equal negative 9 because of the minus sign. Alright, so let's say, for example, you just have negative 1/2. Okay, so if you have just a number can still be written as a complex number. Just a real number can be written as a complex number. Because all you're going to do is rewrite it. So you have negative 1/2 plus 0i. So even if it's just a real number, it can be written as a complex number. It's just 0 times I. Okay, so in this case, you have your real part and your imaginary part, where a is equal to negative 1/2 and b is equal to 0. Okay. Now here they gave you just a real number. What if they gave you just an imaginary number? Let's say square root of 3i. Remember, the I is on the outside of the square root. Okay. The same process that you would use for just a real number to write it as an imaginary form, you would use here. Okay, here you have your imaginary part, you just need your real. So we just rewrite this as 0 plus square root of 3i. Where in this case, you have your real part and you have your imaginary part. Where your real is a equals 0 and your imaginary is b equals square root of 3. Alright. Okay, so let's go to our next couple of examples. Oops. Here we go. Okay, so let's say, for example, you wanted to write each number in the form a plus bi. Okay, so for problem A, let's say if we want to write the number 6. Let's say for problem B, square root of negative 64. And let's say for problem C, you have negative 2 plus square root of negative 63. Alright. So for problem A, that one's not too bad, because we know that 6, since we're missing the imaginary part, we can make that equal to 6 plus 0i. And that's our complex form. Okay. So now with B, first we have to get rid of that square root bracket. Okay, so you have square root of negative 64. And if you remember from the rule, from the page or two back, the previous page actually, if you have a negative square root of b, you just make that negative into an I and bring it on the outside. So we know that this is just equal to I times square root of 64. Okay. Square root of 64 is positive or negative 8, but we're just going to use the positive, so we're going to make it I times 8, or 8 times I if you want to just flip it around. But it's not in the complex form. But we can make it 0 plus 8I as our complex form. Alright, so let's go for problem C, where we have negative 2 plus the square root of negative 63. Okay, now all we have to do is get rid of that square root. So that gives us negative 2 plus, that's a negative, we just make that I times square root of 63. Okay, now square root of 63, again, it's not a perfect square, but it has a perfect square as a factor. Okay, so if we go ahead and we have square root of 63, we can make that square root of 9 times 7. Okay, we go ahead and separate those. We have square root of 9 times square root of 7. Square root of 9 is plus or minus 3, but we're just going to use the positive, so we have 3 times square root of 7. Okay, so that makes this negative 2 plus 3 square root of 7I. Seven times I, or negative 2 plus, clean that up, 3I times square root of 7. Remember, these are all being multiplied, so you can switch them around. Okay. Now, even though both of these are correct, this is actually not in a plus bi form. Because remember, 3 times square root of 7 is your b. Your I has to be the very last thing. So this would be in a plus bi form. Okay, this is correct, but if they wanted it in a plus bi form, it would have to be in this one, not this one. All right. Okay, so let's go into our next group of examples. And this one is going to cover adding and subtracting complex numbers. Okay. So the first thing you want to do is you want to make sure all the terms are in a plus bi form. All terms should be in the form a or bi. In other words, real or imaginary numbers. So in other words, you're going to get rid of any root symbols. Now the second thing you're going to do, you're going to add the real parts to real parts, or add or subtract. Real parts to real parts. And imaginary parts to imaginary parts. Okay, so you're going to have your real parts to real parts and imaginary parts to imaginary parts. Okay. Now, there's one thing I want you to remember. Okay, remember that I is not a variable. Okay, it's very important to remember. But we treat it like one when we add or subtract. When we add or subtract. Okay. Okay, so let's do our first example. Okay, so let's say if you wanted to add 8 plus 4i plus 12 plus 8i. Okay. So since both of these are positive, we just go ahead and drop the parentheses. So you have 8 plus 4i plus 12 plus 8i. Okay, so in this case, we're going to combine our two real numbers, and we're going to combine our two imaginary. Okay, so you have 8 plus 12, which is 20, and 4i plus 8i is 12i. Okay, so again, you have your real to real parts and imaginary to imaginary parts. Okay, just like you would if that would have been 4x plus 8x, you would have had 12x. So you treat it like a variable even though it's an actual number. Okay, so let's go ahead to our next example. Alright, so for example, if you wanted to subtract if we have negative 6 plus 4i minus 3 plus 2i. Alright, so we go ahead and solve this. I'm going to go ahead and rewrite it. So negative 6 plus 4i minus 3 plus 2i. Now since this is negative, we're going to go ahead and distribute that like a negative 1. So then this is positive, so we can drop parentheses for the first part. So you have negative 6 plus 4i. Negative 1 times 3 is minus 3. Negative 1 times 2i is minus 2i. Okay. Now once we get rid of our parentheses, we have our real parts and our imaginary parts. So we combine our real parts, negative 6 plus negative 3, that's going to equal negative 9, and 4i minus 2i, positive 2i. Alright. Okay, so let's do one more example here. What if we wanted to add 7 minus the square root of negative 16 plus 9 plus the square root of negative 4. Okay. Now, if you remember, square root of negative 16, we can just make that 7 minus I times the square root of 16. Okay, remember that negative inside, we just pull it out and make it I. Plus 9 plus I times square root of 4. Okay, so now, remember our first step is to always get rid of the square roots. We don't want any root symbols. We want to just actually go right into the form of I. Okay, so we have 7 minus square root of 16. It's positive or negative 4, but we're just going to use the positive. So square root of 16 is 4, so we have 4 times I plus 9 plus square root of 4 is 2, so we have 2I. Okay, so since this is positive and this is positive, we can go ahead and drop the parentheses. So you have 7 minus 4I plus 9 plus 2I. And again, we combine our real parts to real parts and our imaginary parts to imaginary parts. Okay, so 7 plus 9 is 16. And negative 4I plus 2I is negative 2I. Alright, so hopefully that made sense on the introduction part of it, where basically you're gonna, you're gonna treat the I like a variable, like you would an X if you're just adding or subtracting. Okay, we're going to get into multiplying and dividing in the next one, so I will see you on the next video.